Alrighty. First off, I'm very glad I'm presenting after the pizza got here. I was like, hopefully, thanks that worked out well. So kind of before we get started, thanks for Fang and everyone else at Google for putting this together for the food and the drinks. It's been super nice. First time on the Google campus, and I'm like very overwhelmed by it. So it's thank you for that. I'm with Astronomer, and we help organizations adapt Apache Airflow. We do it a few ways. We have our Airflow platform. We have Airflow training, kind of any service around Airflow. We're kind of your one-stop shop for that. Little about me. I'm a Venture for America fellow. If you don't know what that is, please look into it. And also, please recommend it to any recent grads you have in your life. It's a great program. It's taught me a ton and could not recommend it enough. A little more. So I'm a data engineer with Astronomer. I've been around since 2016 when we first started dabbling with Airflow stuff. Recently, I've kind of shifted more towards like the DevOps side of things. And finally, I'm a very loyal New York sports fan. Summer has not been good so far, but it's all right. We're gonna get there.
The NBA game, by the way.
Yeah, I haven't even gotten a chance to check. So quick overview of what we're gonna go into. Just a high-level overview on Airflow and Kubernetes, and then kind of some of the things that we're trying to do with Helm, Kubernetes, and Airflow, told through user stories that we've experienced ourselves. So rewind the clock a little bit on Astronomer. We did a lot of data services stuff back in 2016 and 2017. Through that, we started using Airflow a ton. These are kind of things that we've made to solve our own former pain points, because right now we're more of a platform company than a services company. Cool. So this is probably pretty high level, so we'll kind of breeze through this part. Airflow is a task scheduler written to programmatically author, schedule, monitor dependencies to different workflows. Pretty much self-explanatory at this point. Recently became top-level project. Some core concepts here, and I think everyone's kind of gone through this really quickly on their talk, so I'll try to breeze through. You have DAGs that are kind of code-based, which is kind of the best part about Airflow. DAG runs, which show you an instantiation of when your code ran with time, and a task instance, which is an atomic unit of your DAG. So one of the coolest parts about watching Airflow through my journey with Astronomer is kind of watching it kind of evolve and grow up. I remember when I first started learning it a little bit, I'm a very like auditory learner, so I would like watch talks online, and there'd be very much about like what DAGs are and how you write DAGs. Nowadays, when you go look at a talk, it's very much like, hey, here's how we're doing these really cool things. You know, like it's kind of the heart of a lot of ETL infrastructures now. So the times are changing. We see, I think, like the list on GitHub has just about every big company out there has Airflow user in there. It's not just some cool project now. It's a grown-up, and it's being treated with like grown-up responsibilities. So lots of use cases, strict SLAs, and it has to run in a lot of environments because the problems that it solves are almost present in every environment. Yeah, so Airflow is growing up. You know, it's a highly available mission-critical service. We've talked to some, like everyone today is like, at least especially here, has had some sort of thing where, hey, I want Airflow to do more things, but it's kind of lacking some things. And if you think of any other enterprise app that you might have in your system, all of these things are kind of like standardized. You know, you're using it at a high scale. There's a lot of security, observability, and some concept of isolation and environments. So kind of before we go into some of the more meat of the talk, Kubernetes. How many of you have heard of Kubernetes or kind of had it tossed around? How many of you have kind of had this experience with it, where it's just like everything's a different tutorial on it and you're just like a bunch of stuff? Yeah, so kind of I'm going to try to be as little of this as possible. But high-level concepts, Kubernetes helps you break down huge applications into smaller, more manageable services, and lets you kind of scale them in a standardized way. You have a few high-level concepts here. Pods, which are just containers or an abstraction to manage containers. Deployments sit one level ahead of pods, one higher level. Stateful sets, which are basically deployments with some stable host name and persistent volume. Daemon sets, which are just pods, replica pods that run on every node. A lot of time logging things will be daemon sets. And namespaces, which are virtual clusters backed by the same physical cluster. Namespace is probably one of Kubernetes' first levels of isolation. The other thing I'm going to talk about is something called Helm. How many of you have used Helm before? Cool. So for someone who hasn't used it, Helm is a package manager for Kubernetes. So pip Python, npm node, Helm, and Kubernetes. So basically, at Astronomer, we've we were running Airflow on just some EC2 machines at one point. We were running a Meso stack at one point. So we've kind of like been along Airflow for the last couple of years, and every quote unquote right way to run Airflow, we've kind of been doing that at one point, or the right way to do something wrong, or however you want to say that. And kind of the conclusion we've come to right now is that Airflow and Kubernetes are a pretty good match made in heaven. So what I want to talk about on this talk is kind of some of the things that we're accomplishing to give us features to our users, kind of taking advantage of a lot of Kubernetes things, and just how nicely that plays into how Airflow is already written. So number one, reproducibility. So user story for us. As a user, I want a dev environment, you know? I think a lot of what some of the previous talks were talking about was like, hey, like I need to test something, I need to run something, like maybe I just want something, I want to try something that doesn't break something mission critical. A lot of times when we talk to customers and users, their kind of company has one giant Airflow box that's running all their code, and kind of getting any amount of reproducibility is not as easy as it should be. And if you think about any other app that you'd want to build your company around, like that's not really a feature, that's like a core need, you know? So you can run something called a Helm Install, which deploys something called a chart onto a Kubernetes cluster. So something like Helm Install your Airflow chart, and what name you're going to give it, would spin up Airflow on your KX cluster. So I ran a Helm install, I spun up an Airflow web server and a scheduler. It's running local executor, and it's connected by some backend Postgres. Nice thing is I can run Helm install again the same way and just give it a different name. I can get another Airflow instance. So right off the bat, Helm gives you the ability to spin up multiple Airflow instances. They're all kind of self-contained. If you notice here, they're in separate namespaces. So now you have multiple isolated Airflow instances. That kind of takes away the first amount of like, I need a testing environment, or I have a new group and they want Airflow. Here's how you standardize that piece of it. You know, just stamp it out. Deploying via Helm gives you a few cool features. Number one, CI setups really like some sort of, we like using CI with Helm a lot. You have an Airflow environment, that's your dev, a push to any branch except for prod pushes to that dev, and then a merge to master merges to master. So it's a nice kind of easy way to do CI. But more than that, environments maintain their own metadata. But other than that, like you can kind of kill them off and give you another one, and there's nothing specific about their environment. The operational overhead of requesting new environments is basically gone because it's just one command. And that really opens up a lot of doors and gives you a lot more possible users. Another thing is observability. I kind of have this like etched up into my brain where I have like, oh, I'm looking at Airflow, everything's running, everything's green, we're good. And then you realize that nothing ran. So as a user, I want to know that Airflow hasn't run any tasks before Friday at 5. Because if you look at this, you're like, all right, I'm good, like everything's good to go. And then you get an angry email from someone saying like, none of my data's there, like why didn't it run? So a lot of times what we see this is because of the scheduler. You know, if the Airflow has great built-in reporting things, if a task fails, you know, get an error email to PagerDuty, to Slack, kind of wherever. But if a task doesn't run, then like you're kind of out of luck. A lot of times that's due to the scheduler. The scheduler starts heart beating, or kind of that piece goes down, then it's not really a great user experience, and it can be the source of some business problems as well. So to solve that, we like using Prometheus. So there's a nice stable Helm chart for Prometheus. So I'll do a Helm install for Prometheus. Prometheus is great because it's also another open source project. It's kind of one of the de facto ways to do monitoring on Kubernetes. Time series database that's pull-based works really well with Airflow's native statsd, as well as with Grafana to get some metrics in real time. So how does this work, right? So in my Helm chart, I'll define an annotation. I'll say, Prometheus, you're deployed, start scraping, look on this port. Airflow will start scraping metrics from a statsd pod. The nice part is that because of the Kubernetes service discovery plugin, when you do another Helm install for a new Airflow, that'll automatically start giving you metrics to the same set of monitoring tools you had before. So it really helps the operational overhead because now your dev environments, even though you can kind of spin them down and spin them back up, you still have some insight into what they're actually doing. Another thing we like to do with this is schedule alerts. So this is just a little snippet from one of our Helm charts. It's a pretty simple one saying that if there's no Airflow heartbeat, send an alert off. It's kind of your first level thing to say like, hey, make sure the scheduler is heartbeating. It's not perfect, but it's better than getting your email at 5 o'clock. And we put out a little email from that. So these gets dropped in our Slack as well as like team emails. Also pretty cool is I saw Ash tweeted this morning that Airflow 10.4 will have a little thing in the Airflow UI that says when the scheduler isn't beating. I think from my own use case, like that'll be kind of huge because it's like the worst when you think your job should be running and it's just like you don't have anything to do. You know, your hands are tied behind your back. Other thing is deployments. You know, so actual code pushes. You know, like set an alarm to make sure you do a code push during a certain time period, or you have something automated that way where a customer needs a fix. Like, all right, cool, I made the fix. Won't go out till 2 days from now, you know, or the next day. And that can be kind of frustrating from a user experience, from a consumer of the data, but also from the like developer itself. You know, like you feel kind of bad when you make a fix, but it doesn't really go into production anytime soon or soon enough. Deployments in Helm are pretty nice because you can just define the tag that your images are looking for. So Helm upgrade kind of lets you update the deployment inline. And then you can use a lot of native Kubernetes things to handle any sort of graceful termination. So let's kind of see how this looks. So suppose I have Airflow running the Celery executor. So I have a Redis, and everything's running version 1 of my code. I do a Helm upgrade. And what'll happen is that the pods running version 1 will start to spin down as the pods running version 2 will start to spin up. We have a health check built in that'll say like, don't really decommission the version 1 pods until the version 2 pods come back on. This is nice because now you kind of push off deploys without any downtime on the scheduler. When it comes to the workers, we actually have something called we recommend something called the termination grace period, which just says that when a deploy comes up, all the workers stop taking new jobs. Stop taking new jobs and finish out the jobs you are up until this grace period. So this is 10 minutes. So all the workers will stop taking new jobs and look at the new code. Stop taking new jobs for up to 10 minutes. If they're still running a job, they'll mark it as a zombie. Or if they're finished, then they'll restart and start running new code. In Celery land, that's not great, but it's still kind of better than having it fail immediately. The cool part is with the Kubernetes executor, deployments are kind of fully graceful. So kind of how the Kubernetes executor works is that the scheduler kind of makes requests to the Kube API and launches pods that run your tasks. Allows for a really high degree of configurability because then you can kind of set different contexts with different tasks, dynamic resource requests, any of that thing. And then for any sort of deploy, because each task is running in a pod that's kind of managed by Kubernetes, you won't see any downtime when you do a deploy on Kubernetes executor. So we're pretty pumped about that. Limits and quotas intake, like it kind of makes it something that you can have a truly continuous delivery system on because no one's worrying about deploys. It does get a little funky if you try to deploy to a job that's already running, but much better than it kind of was before. Yep, so some other nice things you can do on it is a high degree of auto-scaling, define node pools for specific tasks, and yeah. So another kind of take we have on this is that we build a Docker image that has all the DAGs and all the plugins into we build one Docker image and we ship that out to each of the different pods. That ensures that our dependencies are kind of always in line because everything's version controlled and you're running the same version of your code on all kind of components. Really high level benefit of that is that you won't really have a use case where, or the scenario where the scheduler is scheduling one version of your code and the workers are scheduling another one because they're all running the same image. Yeah, so that's kind of all I had, nice and quick there. Thanks so much.
Quick question. This is perfectly aligning with what I really wanted to do. One question I have is, how do you manage? So, for example, your DAG has 10 tasks.
Mhm.
Each task need a persistent disk. So when the pod is deployed, pod goes back. That particular disk needs to get mounted to a different pod. Now, how do you manage that?
Yeah. So that's honestly not a use case that we've really had to come across so far. A lot of our customers are using public clouds in some regard. So they'll just kind of open up an event stream or a buffer to S3 or GCS or something. Yeah, for the persistent disk thing, you have to kind of think about that a little bit to figure out how exactly it would work.
I know how
Go for it.
in Kubernetes you can have these mounted volumes, so like you can have shared file system. But and when you write your pod definition, you specify which file system should be mounted for like this pod. So this like NFS or whatever file system it has to be shared one. It cannot be like a local file system. But that's the way how we can do that and run it.
Yeah. The problem with that is, let's say, first pod gets referred to worker one. It's in a different. Second pod gets referred to, let's say, worker two.
Yeah.
And constantly have to like unmount and mount.
But with NFS, you can mount it to multiple pods at the same time. So it has to be shared file system, and the Kubernetes has full support for that, for like shared file system that you can mount different pods at the same time, like in read-only mode or read-write mode, whatever modes you want.
Question about the Helm chart. So you guys have your own Helm chart, or do you use the one from the main like Helm repo? And
Yeah.
Similar, I guess, with Docker. Do you have your own Docker? Are those public?
Yeah. So everything's public. We have our own Docker image, but we're actually like met with Yarek yesterday, and we're going to try to use the official one a little more. We have our own Helm chart because it kind of bundles together some other parts of Glue on our platform. I think it's pretty similar to like the stable Airflow one. So we have our own, but there's no reason we want to have our own. You know, we just kind of just did that to like get it done. I think like going forward, we definitely want to like have a standardized one.
We'll work together on that.
Yeah.
And if I was to pick a Helm chart today, let's say I have a Kubernetes cluster, should I go to Astronomer's Helm chart or to the stable repo, or what would be the trade-offs there?
Yeah. So I'm pretty biased. I'm going to say the Astronomer one, of course. I think in general, like if you just want Airflow itself running, like on a Kubernetes cluster, the stable one was designed just to run Airflow. You know, with the Astronomer one, it's kind of built to like run other parts of our platform. So we bundle together like Elk stack or EFK stack, some of our monitoring tools. We have like our own UI and all that. So if you want like the kind of the full experience, I would say the Astronomer one. If you just want to like get something up and running, probably just the stable one. Depends on your use case, you know.
I noticed that one thing was outside of the Kubernetes, which was PostgreSQL database.
Mm-hmm.
So do you need do you run several different databases, or on this one Postgres instance, or is there a way to have it also automated, like that you can have different databases for different production and development environment? Yeah.
So we have the Postgres sitting outside because a lot of our customers are running on cloud environments. And a lot of the cloud managed Postgreses, like you can't really go wrong with them, you know, like RDS, Google Cloud SQL. The way we do it is each Airflow deployment gets its own database within that same Postgres. I think if you wanted to give it its own that way, like its own different Postgres cluster, you could. It would kind of depend on the use case. You know, is that kind of overkill if each Airflow is getting its own Postgres cluster? Depends on the use case, I guess.
So working at Astronomer, like, what are some of the more common pain points that you see customers have when using Airflow? How do you guys manage that?
Yeah. So a big one is the local test environment for your DAGs. I think that's kind of something that everyone's come across running Airflow is like, I just want to write my DAG and just make sure it works before deploying it out. We bundle a little CLI tool that's like based around Docker Compose for that. But it's still not a great solution because it's more like, it just gives you a way to run Airflow locally. It doesn't really help you write your DAGs. So a lot of, I think, the work in this coming year is like going to be around that piece. Like, what's the user experience like writing a DAG, you know? That's definitely one. I would say another one is kind of just like the docs say it a million times, right? With the scheduling piece, like the schedule, the execution date, and the relation to the start date. But like somehow making that a little more intuitive. As a first-time user, it's kind of easy to like gloss over that. I think those are the biggest two, right? Like unit testing DAGs, trying to make sure your DAG works, and just the general wrapping your head around scheduling.
That's actually a really good point. When you're talking about unit tests, you have your DAG, which kind of describes the order in which you should kind of do things. But you can have your business logic be somewhere totally different, right? And that can be imported into your DAG. So when you guys create Helm charts, do you guys do so in such a way that the business logic is meant to be like in one place, either like in DAG or like outside of it?
Yeah. So I think for the most part, like we think that the DAG should host the business logic, Like that's kind of what a DAG is. It's like an expression of your business logic in Python. Kind of what that business logic really needs to run depends on a use case basis. So like if you need like some local helper function or something for your thing to run, like we like to bundle everything into that Docker image, so it supports that. So the Helm chart itself probably doesn't contain too much of it. It's probably just what we build out into the DAGs image.
Can I run my own Docker image on the Astronomer platform? How would I go about it?
Yeah. So there's an open ticket on that assigned to me, and I started working with Parekh on the Debian-based image. So hopefully soon. The way it would work, so we have a master image and we have an on-build image. So we have had like a lot of times what we do is customers will build our image and then kind of inherit from it to layer anything else on top of that. You still have to use some of our stuff on that. So ideally, it's like you have our image by default, and then you can kind of specify an image tag to use the base Airflow image, and it builds that. I think that's kind of the golden standard that we want to get to. Right now, not, but like in probably a month or two, like yes, yeah. Yeah. All right. Thanks, everyone.